interest of respecting everyone's time, I will call the meeting to order at 6:04. Josh, will you take roll call?
Sure.
Thank you.
Commissioner McCoy,
Here.
Commissioner Mirsky,
Here.
Chair Lenski,
Here.
Commissioner Zucker,
Here.
Commissioner Schreiber.
Here.
We do not have quorum.
Okay.
And Councilman Eaton is here but stepped out for a minute.
Yes.
Okay, we have the agenda in front of us. As folks saw in the preview of it, relatively light agenda today. We did add a last-minute agenda item, the presentation on battery storage that Commissioner Hookham will be providing. Otherwise, we'll just cover our usual items and committee updates. Do we have a motion to approve the agenda?
So, second.
All in favor?
Aye.
All opposed? Okay, approve the agenda. Approval of minutes. Josh sent the minutes out for review. Do we have a motion to approve the minutes?
So moved.
Second.
All in favor?
Aye.
All opposed? Okay, we have approved the minutes. At this time, we will open it up for public input. Any member of the public who is here and would like to speak to us for a couple minutes on a topic of importance to energy is welcome to come to the podium at this time. No public comment? Okay. With that, we'll go on to the energy report. News from the Energy Office and Commissioners.
Yes.
Josh.
So just a few updates for everyone on bylaws. We do have bylaws that actually passed council, so the edits we made passed, which means we can also have 2 youth commissioners on the Energy Commission. So I wanted to kind of share the good news. I know that we had a couple of people in mind, but that's something I guess we can work on to kind of identify who those youth commissioners will be.
Yeah, so is there any timing requirement about when we begin soliciting for those?
I mean, it's just selected.
We would just ask them to submit their application through the usual process, and the
Yes.
mayor and council will review.
Yes,
Okay,
that is my understanding.
okay.
Is there a way to kind of get that information out to the public in case there's
Yeah.
anyone that is interested in that?
Or like an email we can forward.
Right, so we had taken down as an action item when it was ready to be in touch with the U of M Student Government Relations Liaison. Kyla McCallum had visited us here once and said she'd like to circulate that information. And then I'm thinking, I mean, we could draft something up, but I'm wondering if the community engagement subcommittee might be the right group to kind of just take on passing that information along to local schools and youth organizations and so forth.
There was a high school sustainability or climate-related energy group that was starting up too, so I could
Yeah.
look back and try to find that contact.
Great, yeah, and Carlene might have some through the
Yeah.
schools as well.
Can you remind me, was there a minimum age?
Yes.
What is it?
The age range is 16 to 25.
16 to 25, great, thank you. So I think, yeah, it'd be wonderful to get somebody in the younger end of that as well. Like
Yeah.
A high school student or something that,
Yeah, and maybe it would be useful for us to draft a document just explaining the expectations, right? Who's eligible, what the process is for them to apply, and then what our expectations are about the length of time that they serve, their attendance at the meetings, how they participate, and the benefits to them, of course.
Would staff do that, or because it's joint with the Environmental Commission? I don't believe there's any differences between this commission and that commission and the youth representatives, so we should have a common document, it seems to me.
Yeah, I mean, that's one of those things, if we want, we can bring it up to the communications, the subcommittee that deals with it, and just have kind of a draft written up from staff. Does that make sense?
Yeah.
That'd be great,
Okay.
that'd be very helpful.
And so when we go out into the community as council members, we've been announcing it at meetings. I was at a college Dems meeting, we let them know.
Good.
At council meetings, government students in high school have to have a council member sign their agenda and sit through one of our excruciating meetings. And we tell them that these are available, but I think that if we went through our usual press release sort of thing and put it out on social media and stuff, that would help too. Additionally, at the last council meeting, we passed a resolution that will change the process to start up the appointment process. So, as I recall, it's an ordinance amendment, so it needs to be passed at the next meeting as well. But we as a body will make recommendations to the mayor. And so, as openings come up, I have access to every application that the city has received for the Energy Commission. You know, we can share that information. We may want to form a subcommittee just for membership issues like that, you know, who to recommend to the mayor. The mayor, under the city charter, has the absolute right to appoint anybody he wants, but this will initiate the process with us at least making a recommendation, and then he can do as he pleases.
That's good. Comes from all quarters that way then.
And yeah, this will be true of every board and commission, not just this one.
Yep.
Thank you.
Oh, one other thing, I'm sorry. Actually, the bylaws didn't pass at the last meeting. The resolution that passed changed the statement of purpose for this committee, or this commission,
Yep.
and changed the membership, but it did not include the bylaws, and so we'll have to circle back around and make sure that they get on the city council agenda.
Okay, yeah, I apologize, I thought that was part of it. I'll reach out to Chris Frost then, and we can.
Unless I missed something, I might have voted on something that I didn't see, but the actual resolution that I'm looking at from the last meeting was just the purpose and the membership, so.
And Josh, one other thing regarding youth members, I recommended to Emily, I assume she's done this, to reach out to some of the interns that we've had who are also connected in with a lot of the student groups at U of M, as well as Grant Dukas, who you remember, who's Students of Clean Energy. And, you know, there's the membership of those groups is on the rise, so tapping into people who are already passionate and informed and engaged makes sense.
Yep. All right, a few other updates. As far as the energy TAC and A20, we have finished going through the ideas and ranking them. Currently, we have a contractor who the ideas are now going through. We're kind of putting a finer point on the greenhouse gas impacts and some of the financial costs. We're hoping to have that kind of turned around pretty quickly here. There's another town hall that'll be happening.
Sorry, can I ask about that?
Yes.
Is that the consultant that you
The
guys were
consultant.
talking about hiring? Who
Yes.
can you speak about who you hired?
Elevate Energy.
Elevate Energy.
Yes.
Okay.
Yep. That's a group out of Chicago.
Okay.
Yep.
And they are, I remember Missy shared, I think it was last month, a little bit about what they were doing, but can you speak a little bit more about what they're?
Yeah. So giving greenhouse gas numbers to each of the top ranking ideas, as well as giving kind of a rough estimate for cost to
Okay.
implement each of the different ideas that were listed by the Energy TAC.
Okay.
We have a town hall coming up the 22nd at Pioneer, which kind of puts the two bookends. So the original one happened at Cobblestone. This is going to be the ending of, I guess, the energy tax and kind of wrapping everything up. So that's going to be at Pioneer, like I said, February 22nd. And then we also have a forum that's tied to the mobility TAC. So we just recently had Energy TAC Forum, which is part of the sustainability forums, happen on an annual basis. And the next one's mobility, which will be on Thursday at 7 p.m. Downtown Library, February 13th. So that's all I have for staff updates.
Can you talk a little bit more about the town hall and what's coming to that? What is the intent?
Yeah.
And how will the time be? Because it's like 5 hours long, right?
Yeah,
How
so
will the
there
time be
is,
used?
yeah, so there is, I guess the way that the original town hall at Cobblestone, was kind of programmed, we had three major pieces. So one of it was public input, the other one was the tax, so having kind of the technical advisory committee, and the last piece was partners, so kind of nonprofit partners throughout the community. And really what the final town hall will do is kind of wrapping up all those three. So in many ways, the TAC has gone through, kind of created a list of priorities. We'll have already the numbers, so we'll have kind of a finer point on the greenhouse gas numbers, the kind of cost to each of these. And we'll kind of be doing almost like a TED Talk, I guess, is how we've been pitching it, that breaks down the top ideas to the community and really helps to get their feedback. It also brings in that kind of community leg of things. So the community, throughout this whole period, they've been given 3 surveys to kind of have input on the ideas that we're coming up with in the tax. And I think this really creates an opportunity to get their feedback on this kind of finalized list, as well as obviously having our partners there, our nonprofit.
Are you sharing the results of the surveys then at the town hall?
Yes.
Okay, so the results of the community surveys, the results of the TAC prioritization, and the results of the consultant's analysis, kind of
It's-
those 3 pieces?
It's basically, yeah, it's kind of a culmination of all the work that we were doing from beginning to end. I guess that's the best way to kind of put it.
Okay, but then asking for additional feedback on those? Is it a presentation? It's an
It's a-
open
It's a
conversation?
It's a presentation with the public input.
Okay,
Is there going to be a youth forum as well, or roundtable or something? That was planned at one time, right?
I'm not sure.
No.
I would definitely reach out to Missy to get more details on that part.
okay. Anything else, Josh, from the city's perspective or energy commissioners? News or updates? No. Okay, then moving right along to our next agenda item. Commissioner Hookham has brought us a presentation around energy storage.
Sounds great. Do you have control of the slides, Josh?
Yeah, if you want, I can just pass you the keyboard. Did you need to, do you want to?
Just the mouse probably is fine.
Okay.
Yeah. Thank you. I think my hand will work.
Is that a boxing injury?
It was not energy related.
Slicing avocado.
Oh. Long story. As you get old, things happen, right? So I did this kind of on a quick notice. Somebody asked for some ideas or thoughts on a presentation. Some of you have heard me talk on this topic before. There's other folks here who are studying this in detail as well. So I'm talking a little bit about tonight distributed energy resources. So when we talk about it in CMS, we usually are talking about it from a larger scale. So a DES or DER might be serving a specific group like a city. You can also think about what I'm going to talk about today about doing it locally. And one of the things that you know about and probably have heard me talk about in the past is dispatchable versus intermittent power. So when the lights come on and your furnace kicks on and your motors start, there's got to be something running.
Why don't you get your microphone a lot closer to you, just in case there's somebody watching online?
Okay, my voice will wander too, so thanks, John. But anyway, so if you turn a light switch on, we need to have something running to support that. It's got to be electron flow to the device. One of the challenges we have with our renewable sources, for the most part, are that they're not dispatchable, they're not readily available, they may or may not be available at a specific time. So we're looking at solutions that can be used to backstop or smooth those renewables. So batteries offer that, and you've heard me talk in the past about microgrids and how you can apply a battery in different formats to take advantage of or enable the greater use of renewable energy to turn on light switches and service our loads. So just a real quick update today of what's going on in an industry to let you know what we're doing, a little bit of highlight of what's going on. I have a few definitions in front of you. I'll use the words a lot in my presentation. So bulk electric system, that's the grid, that's the wires that run around town, that provide power. Well, I'll show it to you in a minute on how that looks physically. I talked about distributed energy. That's where we generate electricity close to the load. Energy storage is where we store electricity for the future use of that electricity in a format or structure. It could be in a water pond like we have at Ludington, or it could be in a battery. There's a lot of ways we can store energy and use it later. Not so much all efficient, and that's important to recognize. Generator interconnect, that's where we bring in electricity sources and connect them to the grid. That's an important interface between a utility service and a DER perhaps. So think about generator interconnect as that key point when everything connects together, and that design of that interconnect's gotta be perfect. And I know, like Carlene, you've got your new solar system that connects to the wires. Probably that generator interconnect was a little stressful, but you can make it happen. It can get done. And there are ways to make it work. So a lot of work goes on behind the scenes to make sure that's safe. Parallel is when a generating system works behind the scenes in parallel to the grid. So think of a building like our city hall. A parallel system might be a generator that's on site generating electricity locally, whether it's solar or something else, and the grid providing the rest of the power. So they're working in parallel to one another. Islanded is how a microgrid works. When the grid goes away, the microgrid is able to withstand that scenario where it's no longer parallel, but it's actually islanded. So we call it islanded. Think about when you go to Oahu and you're sitting on the island in Oahu, that's an islanded grid. It works as one specific islanded location, hence the word island. And flowback is where we have a scenario where a microgrid or a renewable source or a battery might be dispatching the power backwards onto the grid. So think about technologies you're starting to see visible in vehicle to grid. We're thinking about batteries that can provide power back locally to a grid scenario. And then lastly is the microgrid, which is a segment of a grid that can be operated by itself without connectivity to the larger grid. So I'll show you what that looks like here in a second. So quickly, and I'm not going to get into a lot of detail here, but the pictorial here shows a grid, and it shows a lot of different things connected to that grid. From left to right is the main power grid with lots of different types of generation hooked on to an island of transmission with, you see the big tall towers, you see the big lines, those are transmission lines. They're usually at high voltage, and they're done that way for efficiency reasons. And then we step down that power locally to where you need to use it to a lower voltage. Every time we step up and step down, we have losses. However, it's a more efficient way to transmit electricity is at really high voltage, really low amperage, more efficient, less loss in the lines, but still causes us some aggravation. That's the way the system was designed. It was designed to basically provide electricity from the left to the right. And now where we're going into is more distributed energy. So we're seeing interest in doing things locally at cities, at homes. And you're seeing power flow in the red lines. You can see the power flow now going two directions. Sometimes the power flow comes into you, sometimes it doesn't. And it causes a lot of stress to a system that was designed to be one way. And we're still working through this to find out how far we can go with our grid to see what kind of loads can be added safely and reliably, because every time somebody adds a new system to our grid, the lights may or may not come on if frequency's out of whack or voltage goes out of whack. There's a lot of things happening in the wires and in the system to make sure we deliver electricity to you safely. In the great blackout of 2003, I can't tell you how many neighbors came over and said, well, why can't I turn my toaster on? Well, you know, it just takes a couple amps. Well, the whole grid's down. So guess what? Your toaster's down. There's a lot to providing power, and I think a lot of people take it for granted. The wires are there. I'm paying 8 cents a kilowatt or 10 cents a kilowatt hour, and I should have 100% reliability. It takes a lot for us to do that as a utility and electric industry. So challenges ahead of us. So the future reliability really hinges on balancing the technologies we have. DTE, Consumers Energy, a lot of utilities have invested a lot of money to make our grid more resilient. I work on the storm team with CMS, so I see firsthand when we have a storm how much better our grid is. DTE's grid performs better than it did 5 years ago, simply because we've added technologies to enable us, like reclosers, where a fault used to take down the whole circuit. Nowadays, the fault, if it's not bad enough and the recloser can close back in, just goes past the fault and continues providing electricity, maybe at a small window of time later, but at least you have power back on. So there's a lot of technology that's being layered into the grid to make it smarter, to make it more enabled, to communicate better. And that's what's going on behind the scenes. All those technologies in smart grid are helping us transform to more two-way power flow. So I think that's an important fact.
Chuck, what's the one acronym, Scott, what is it again?
I can't go back.
SCAD,
Supervisory control,
Data
and
acquisition.
data acquisition.
and data acquisition.
And.
So think of it as your PC. There are multiple platforms that it works on, but now there's a lot more field information coming back to us. In the old days, you'd send out a crew. If something broke, send a line crew out in a bucket truck and they'll go fix it. Nowadays, we can diagnose over SCADA what's happening on the line, where the fault is, and be pinpointing our response. And so that data acquisition is really important. Floods us with information, but it's really an important system. I mentioned energy storage. There's lots of ways to store it. I won't go into detail. You've heard me talk about this in the past. We have some that are really big scale that we can store megawatt size storage that are being deployed now. Batteries you hear a lot about. I'll talk a little bit about that in a minute. And then we have even smaller scale, very fast acting devices. I'm actually working on a flywheel project right now. So we're looking at putting in flywheels to react to disturbances on the grid in a faster format. So we have to use these technologies to the right fit. The important thing here is that they're coming down in price. They're becoming more available as there's more demand for these kinds of devices moving forward. This is just a quick snapshot. Don't get into the weeds of it. The vertical graph is how fast or how long these systems can operate. The right, flat horizontal line gives you from kilowatt scale all the way to gigawatt scale. So you, again, the same thing, pumped hydro, which I'll talk about in a minute, offers lots of hours of storage at high volumes of output. So really a good solution for a grid as we're transitioning to different types of technologies for generation.
What's CAES?
CAES.
Compressed air energy storage.
Okay.
So we either put compressed air, we can pump it underground. Michigan's blessed with lots of salt mines and old oil wells and things like that that can be used for compressing and storing either air as a compression device for energy storage or to store carbon if we choose to from what's called carbon sequestration. So Michigan's blessed with that. We also use a lot of our salt domes and facilities like that to store gas. So this year we haven't had to use as much natural gas, but we have stored, Michigan being the #1 state in the country with storage capability for natural gas, really important. But for generation of electricity, we can use those caverns, pump it full of compressed air, and then let the air out through a turbine and spin the turbine and create electricity. So there's only 2 of those in the world at utility scale, but there's a lot of interest in those now. We happen to have the world's 3rd largest battery in Ludington. We'll soon have, and I think it may have even happened, I may be out of whack with this timing, but over 2,000 megawatts of pumped storage. So you can see in the,
It's over 2,000 megawatts of.
today it
pumped
is,
storage,
and I
yes.
think we're close to, if we're not there, we're very close to being at the new nameplate of 2,000 megawatt, 2,172 megawatts. You can see the pictorial on the bottom, looking at it from Lake Michigan. You see a lake that's up above on a bluff. If you ever drive by, you can actually go onto that visitor stand and off 131 or 31. Anyway, along the lake there, and you can actually see this whole thing, and it's pretty fascinating. But built way before we realized how important it would be to our grid and provides significant capacity and capability to the state of Michigan in terms of its ability to meet needs for capacity energy or what we call ancillary service when our frequency or voltage have challenges. So Ludington is a very great resource we have in the state of Michigan that is what we call the big battery.
Just question on that is, and you get at this a little in the last bullet point, but what do you see as future potential for pump storage? And I'll just reveal my bias and put on my professional hat on this. I work at National Wildlife Federation, and just called by reporters just today because there's a proposal for a new pump storage in Georgian Bay on the Canadian side. I also sit on the Great Lakes Fisheries Trust Board, which came as a result of a lawsuit filed by my organization because of the fisheries damages done by this plant. So the question is kind of, you know, do you see big potential for this moving forward? It wasn't originally designed with renewables in mind, but I know it can be used that way.
So I could talk about this for a long while, actually. I testified to Congress on pump storage and what we could do in this country with pump storage, not a year or two ago, and it fostered really interesting. I've never been in Congress before where I had the whole House Energy and Commerce Committee in front of me, peppering me with questions, why don't we do this, why don't we do this? And we had a dialogue going between myself and several of the representatives about, in Virginia, they have coal mines. Well, they're not going to use the coal mines. They're underground caverns that can be used for something else. We're talking through the whole idea in front of everybody else about, could we use those for pump storage, where we actually flood the cavern, really very limited impact on environment because nothing really lives down in those coal mines. And it's a cavern that could be used for something like vertical generation. So we walked through it, and sure enough, now Virginia and West Virginia both have initiatives to do pump storage in their states with coal mines. Typically, we think about it as lakes or like Ludington. I know of one other site in Michigan that we looked at pretty heavily for this. It's really difficult when you have the environmental perspective. To actually permit Ludington today would probably take 15 years. From the time you thought about it, modeled it, bought the land rights, did all the environmental permitting, NEPA and everything else. When we have to do integrated resource planning, we're not looking out 15 years. We're looking at 5 years, but potentially in that range. How do you schedule something? How do you spend that kind of money in advance of a project that may or may not make it with that kind of an impact? It's really difficult in this marketplace, in this current state, to permit pumped hydro.
Yeah, maybe you'll get to this, but I also wonder on the efficiencies, because obviously, it's you have a net loss of electricity, right? Because you're pumping it uphill and then it's coming back, and just by thermodynamics you lose. But I don't know how that compares to other storage type pieces. And maybe again, I don't want to take us too far down this one particular piece, but I'd be curious your assessment, how it lines up. I haven't heard anyone analyze that.
Yeah, again, I'd suggest we talked about that offline. I could for a while, just for the purpose of the question though, which is a good one. It's really an arbitrage scenario. So our power grid, the way it operates, and a lot of people don't know this, but the utilities generate electricity for their customers, sell that power to MISO, buy the power back from MISO and distribute it. So it's kind of a strange model. It's been in place since about 2000. The nice thing about what Ludington does in a pump storage is we can pump the water up to the pond at night when the rates are low and let it down during the day when demand is high. If you looked at our demand curve, you'd see how this matches up really well in Michigan with our demand. And that's the real glory of it. It's a large amount of power in a space that really fits well. It's environmentally sensitive. We have probably the world's most innovative fish nets and things protecting the intake, so we're not bringing in Lake Michigan fish. A lot of work has gone on to fine tune this. In fact, the efficiency of these hydro turbines are some of the best in the world. They're maxed out now. We can't expand them any further. But I could talk a lot about the efficiency impacts at night and what we see. But it's still, in my mind, one of the best technologies we could use going forward to help move away from, if you will, a carbon-based generation.
Okay, thanks.
Just a quick map of where we use energy storage. So we have energy storage being used for our generation side. You're starting to see more and more where we're replacing gas peakers with battery storage. Batteries gotten to the point where it's scalable at large plays. We're seeing it mostly out in California where power prices are really high. I mentioned energy arbitrage where we're doing night to day peak shifting, which is very effective. And it provides other services like Black Start. We're working on a Black Start case as well right now with batteries. Obviously we can inject batteries at transmission level. That's the current MISO marketplace for growth in battery storage in our space, to inject it to either non-wire alternative instead of putting in transmission, or to solve a particular power problem at the transmission level. And then I'll focus on the far right, customer behind the meter. So we're seeing a lot of interest in solar plus storage at people's homes. That's been driven by the cost of electricity being at a point where it makes some sense potentially to add a battery. The cost implications are there perhaps. Provide some UPS-based power if you have a storm. So we're seeing more interest in people coupling batteries with their solar on their roof. And so that's being aggregated in different places. We're watching to see how that ends up rolling forward on a larger scale. But it is happening at a small scale at homes. So what's driving the current growth in storage? Obviously, it's helping renewables become more dispatchable. That case I mentioned earlier, the battery costs are coming down. We're seeing some press in the market. FERC has asked all the ISOs to actually investigate storage and how it could be used in their marketplace, mostly for ancillary service, but for other reasons. And we're seeing that it's able to be permitted very quickly. We don't have to worry about emissions so much. We're citing it in a space that may not be best suited for large-scale generation. Perhaps local batteries might fit better in terms of launching it quickly. At the national level, this is basically a graph, if you go from left to right, what's happening. The curious thing here is if you look at 2013 and you look at the storage that's being added, in 2013, the amount of battery, which is the blue bar at the top, was innocuous. It wasn't a large amount of, it's effectively 80 megawatts. Now you're starting to see significant growth in energy storage going left to right in batteries. And batteries, I mentioned that they're coming down in price, have really become the solution, if you will, to a 4-hour energy storage need. And it's being touted as being the next generation of battery technology. In my mind, it's going to be probably flow batteries because lithium ion has got some limitations. It's got some fire risks and other things. We're investigating flow batteries, which I can talk about again in another forum, but flow batteries seem to have a lot of benefits, and it's just taking that commercial step to get them to the market where we'll start seeing their application more. But a flow battery is effectively two big tanks, cathode, anode, and a liquid electrolyte passing between them. Not so much in the way of fire risk, and you can actually use fairly readily available materials as opposed to lithium to manufacture them. So you'll be starting to hear more about flow batteries here in a short distance. Why don't-
Theoretically, do flow batteries have a longer discharge duration currently than the lithium ions as well, which also make them better for utility scale and energy applications because of
Yes.
the longer duration?
So lithium probably has a 4-hour duration as far as how much it can dispatch its full capacity. A flow battery today, I could buy a flow battery that's commercial for 8 to 9 to 10 hours. So you're seeing that capability grow. And obviously having that backstop, if you have a storm that takes out your service for a few hours, maybe lithium will get you there. Probably a flow battery will make it even a more, responsive system for you. So like a microgrid or something like that might be benefited by a flow battery. A lot of research going on throughout the state. University of Michigan's got research, Grand Valley State's got research going on, probably Michigan State as well, on flow batteries. That seems to be the next step.
Chuck, this slide that's in front of us right now, is that to be understood as in 2013 on the left was what was in place and what has been added to that every year since? Is that how to understand that?
These are additions, so.
2013 was also in addition to what had been in place before that?
Yeah.
Okay.
This is just purely the megawatts added
Okay,
in the
additions
United
by
States for that
technology.
year.
Okay,
So
yeah.
not a lot of storage in 2013, even less in 2014,
Yeah.
kind of economic impact there. But you're seeing the shift in technology growth. 2017 was kind of an anomaly. They were expecting greater growth. We had some things happening like the shortfall in supply capacity from South Korea impacted us. I was trying to secure batteries in 2017 and couldn't. And now you're seeing that growth in manufacturing worldwide catching up to the demand. And there are projections that this is really going to take off here over the next few years. We're watching it, I think, I don't know that I believe that, but we'll see where it fits. It's a interesting balance. So So why is it limited in Michigan? We don't have a lot of energy storage in Michigan. I mentioned Ludington. There's not been a lot of batteries built. One of the big drivers is MISO, that marketplace we work in where we buy and sell electricity, has no market for a battery. There's no payment to us. If we had a battery, we dispatch. If you went to Ohio, let's say, which is part of the PJM interconnect, you can actually build a battery and be paid for it. But in MISO right now in Michigan, Wisconsin, Minnesota, other states going south, that MISO marketplace footprint doesn't have a market. So nobody really builds much in the way of batteries there. That's changing, but even today, it's still in that same space of not a lot of drivers for building something like that. So we've looked in other places, and I'm on the non-regulated side, so we've looked at battery storage. I'm actually building one in Ohio that I'll talk about in a minute. So there are marketplaces for batteries, not so much in the MISO space. The other thing is, relatively speaking, Michigan's electric rates are fairly low. If you went to the California, Massachusetts, the coastal areas, you'll see the prices for electricity much higher. That drives interest in putting in battery storage, where that price point comes down and matches up better.
Chuck, thermal is natural gas turbines, or is that what that is?
Thermal would be, ice. We manufacture ice during the night and use it for air conditioning during the day, that kind of technology, not so much electric generation.
Okay.
So I mentioned costs coming down. Don't want to talk about this too much, but lithium, if you went from 2000 to 2015, this curve, you see dramatic price difference and cost to the market. So we're seeing that trajectory drive us and look at this really strongly. I think by the end of next year, we'll probably have had 5 or 6 batteries installed, all of which are lithium, to see if they have a benefit moving forward. But I think we're really starting to look more at different types of technologies going forward. At a smaller scale, at residential level, you'll see it in your calculators, you'll see it in your cell phones. It'll still be the lithium technology, but I think you'll see larger scale batteries coming about as their price points follow a similar trajectory. You've heard me mention this maybe in the past. I'm not sure even Teresa knows about this one. The Innovation Center in Jackson, this is a project I developed a few years ago and have been helping get it to the finish line. Interesting story. We decided we needed to invest in a microgrid. We had a building in downtown Jackson that we have office space in. We own the building. And in 2015, we went through an upgrade where we basically gutted an old 1938 building, put in energy efficiency in terms of lighting, HVAC. The plug power is very low. So the building itself is very efficient already. We decided it was a great place to put in a microgrid, so we actually put in a battery. The long story of that scenario was that particular battery, its sister battery caught fire in the test lab, and the battery manufacturer said, stop, you can't use that battery indoors, it needs to go. So we went through a 9-month hiatus of trying to find another battery that would fit our bill, and we did. It is now in service at the moment. It hasn't been commercially accepted yet. We're still going through commissioning. It's nominally 100 kilowatts, so think about a 3 or 4 store building with lights and plug loads, not a lot of high industrial use inside, but it's a pretty good sized battery. The battery was sized so that it would be able to run the building, all of its loads, for about 3 days. So it's got a pretty substantial amount of capacity to it from the building point of view, especially over weekends. We'll be able to run off grid. It's got a solar system that we integrated on the roof. It's got electric car chargers that are integrated at the ground. And it's really a pretty cool system. So it's going to serve as a living lab for us to watch and see what we can do with our customers who are interested in microgrids. And one of these days soon, I hope to be able to offer anybody that wants to come and take a tour of this to come see it. So we're pretty excited about cutting the ribbon on this one and getting it done. It didn't set any records in terms of getting it done on time, but it's going to provide, I think, some learning benefits for us as a company. And this is kind of what it looks like from a one-line point of view. This is an electrical diagram. Here's where the grid comes into the building. It goes through a switch. It has a meter up at the top. We basically have taken over the building electric inbound. Where this line is coming in used to go all the way around here to here and run into switchgear, which are all the loads. So all the switches, kind of like your house, it had switchgear in the basement. What we've done is integrated in there a new set of switchgear that has a battery at the bottom, an inverter, and switchgear with protective relaying that enable us to monitor what's coming in so we can watch the power quality of the grid coming in, and if the grid goes black, immediately interject and open the switch and interject the battery into our power supply to the building. It was designed to happen seamlessly so that we don't trip any loads, so it'll be interesting to watch that take place. We're gonna do some simulations coming up. But it will carry the full load of the building, like I said, for an extended period of time. So it's a pretty simple pictorial in terms of how it came together. I'll tell you, this whole protective relaying and making sure it's safe took a lot of extra effort. We took a lot of time to make sure the battery was safe. We have a lot of backup systems in place, so that if we had a fire, we have provisions in place to overcome that. Unlike what you've heard in industry, we're ready in case something bad does happen, and we've taken lots of steps to make sure it doesn't. I mentioned the project I'm working on now. This is gonna be one of the first hybrid projects in the country. We had an existing wind farm, 100 megawatts in Ohio, pretty good size generating capability, pretty reasonable capacity factor. It's been readily available almost all the time. We have a limitation on how much power we can inject into the grid. So we thought about what can we do about that and how could we learn from it. So we decided to build on the property we own around the substation, a pretty large, right now it's 3.5 megawatts solar array. So it's a pretty good sized ground mounted solar array. And we're adding a 1x4 hour battery. And we'll be able to charge the battery with wind or solar, dispatch the battery on the fly when it makes sense. We have about 5 or 6 different use cases where we'll be able to take advantage of that battery to watch how we can integrate it into the market and then learn from that to expand it and use it in other places. So it's really a cool technology we're adding, where it's purely renewable, purely dispatchable. And I wish I could have made a bigger battery because I think we'll be taxing that battery every day, but it's an interesting living lab, if you will, down in Ohio. Graphically, this is a solar graph, so you'll see that it's effectively charging along here, or it's actually discharging at different times. You see the discharge curve, and you see the sun come up, and the solar is generating to the solar side of the grid. In the blue, it's charging the battery, and then the battery's charged, and at night it can shift and do load shifting at night. So the same kind of a mindset where we can use the solar during the day both for meeting peak demand as well as charging our battery, and then using the battery as a load shift to use it at night. So we're really excited to see how this works both with wind and solar at the same time, and to have additional generation capability. So that's kind of the technology of the future that we see happening quite a bit. And that's all I had for you tonight. So I'll be happy for any questions or.
Question, so the distributed generation side with all solar panels, everything, are you starting to get into looking at distributed storage and vehicle to grid and applications of lots and lots of 100 kilowatt batteries that customers pay for and are sitting around in garages 90% of the time?
Yeah, there's a project in Washtenaw County that you'll probably hear about that's distributed solar. The owner wants to have it be a microgrid that's going to serve as a resiliency hub. I don't want to talk about it because it's not my project, but it's coming. You'll see it. It's got a lot of visibility and backstop. So I think my understanding is it's in site plan review right now. So if you Google that and you want to talk about distributed solar, I was at a facility in Alabama that basically had its own generating plant that was a microgrid and had 63 homes attached to it, all high efficiency homes, all with solar on the roof, all with batteries in their facility. The battery in each home was basically its resilience, but it was served by this microgrid. So you're starting to see that build up in smaller scale. I think it's just going to keep scaling up. There's been announcements in Oregon, I believe, Arizona. There's several larger scale communities looking at doing that.
I have a question going back to the purchasing of battery power in the MISO area versus others. What is that, what's the reason for that? Why do some areas why are they purchasing battery stored electricity? And why is in the MISO area not?
So for an individual to purchase it, no?
No, on the grid scale.
PJM
Why
versus
doesn't
MISO.
MISO
Why doesn't MISO have an ancillary services market the way that PJM has an ancillary services market for batteries?
That's a political answer. I don't know if I can.
Oh, so it is, it's
say
not
the
a
right way.
matter of, well, because, MISO, it's got plenty of electricity that it's generating from other sources, and there's absolutely no need because we're not using it. I don't know.
There's a very low penetration of batteries in the MISO footprint as well.
There's the largest battery, we came in second, we were gonna build it and we didn't, it's in Indianapolis. It was built ahead of the curve. They thought MISO would adopt energy storage markets and they would be able to dispatch this battery, they'd be in the market right out of the box, they capture. The goal in most grid operations or utility operations with an ISO that covers the market is to be the first entrant, because the first one in gets the big payment. As an example, the first wind farm in Michigan has $120 per megawatt hour sales contract. If you built it today, it would be in the $28 range. So they were pretty smart 8 years ago, 9 years ago to get in the market early. They got the big contracts. Now things have tailored off because costs have come down. For whatever reason, MISO wants to wait and not do storage. They want to watch and see what happens in other ISOs, let them learn first and then adopt the rules, probably at a lower price point. They don't want to suffer that
Price
big
of entry.
curve, right?
I think another piece to that, and correct me if you think this is inaccurate, but my understanding also, MISO market is largely regulated. The utilities in MISO are largely regulated. In PJM, there's a lot of unregulated markets. And in a regulated market, the utility has a construct in which it is safe and, under most reasonable conditions, there's going to be a reasonable incentive to invest in having sufficient generation and sufficient capacity. And in PJM, and other unregulated markets, they have experienced challenges where they have not had sufficient generation or capacity built, and the challenges that come with that in terms of the ancillary services. And so those markets have put in a lot of, if you read those markets rules, they're hundreds, thousands of pages of kind of minutia about different services they're selling and trading and all to, I think, compensate in some ways for the lack of that kind of stable regulatory construct. And so I think MISO doesn't feel the need for it in the way that PJM did.
Yeah, we operate and we're in different service territories. MISO is probably the easiest market rules, but the most difficult to get any kind of traction in terms of new technologies or new advancements. It's just the way it is. It's just how they operate. They just have different philosophies.
How far out then do you think that the battery technology is for MISO? Do you think? Is it 5 years, 10 years?
So what we call SATA, or storage as a transmission asset, so I had that one picture that showed where you can plug in battery storage at a grid level. That's probably a year or two out. Storage as a distribution asset, maybe right behind it. Offering up an ancillary service to others or a frequency regulation, I'm not sure it's really gonna come. I think they've already figured that they have enough. So it's just a different
But
philosophy.
it could come to this area through other mechanisms, right? The Michigan regulatory environment, if the MPSC is interested in seeing more of these or supportive of utilities proposing and piloting more of this, it could come through that mechanism without necessarily
And the
MISO.
utilities will continue to pilot different types of batteries into different applications. Consumers Energy has a 1 megawatt battery near the Western Michigan University solar installation, and we're running tests on that and running use cases there. We're running use cases in Circuit West on a 500 kilowatt battery that's near solar in the urban settings, and then in the process of installing another 500 kilowatt battery with solar for another use case. And so you're going to start seeing more batteries as distribution assets. Then you'll start to see more batteries as generating assets. And that's the other thing that's complicated from a market's perspective, is what use case are you going to use for that particular battery? Are you going to use it for frequency regulation? Are you going to use it for solar smoothing? And which one of those things gives the greatest benefit for customers at that particular time? So I would say that you'll probably start seeing more and more of those over the next 5 years.
There's an interesting challenge, and I think everybody in Michigan needs to understand that, and that is that I mentioned MISO coming into play in that window of time, and effectively, before, utilities would generate electricity for its customers, and the state would regulate it. Now, the utility generates electricity, sells it, and buys it from MISO. The state still wants to regulate it, and they still want to tell everybody what to do, but they're not in the market. And it causes some friction, and I've had to testify and talk to our friends in Lansing about how that's different, how that model doesn't reflect the old days. Take your hat off and think about it a different way. And there's certainly, we're all in the same mindset of, if there's a storage application that makes sense economically or physically, let's tackle it. But there's other solutions typically to the problem, and it may not involve a battery. So we need to work together. The market needs to tell us and give us signals on what the investment profile should be. Where do we put our money? But the state can, shape that a bit, but they need to listen and watch. And unfortunately, sometimes they get ahead of themselves. Maybe they go to California, see the big batteries, and say, let's build big batteries in Michigan, and it's not the same fit. It doesn't have the same alignment with what we need in Michigan. And we're trying to keep the rates down too, and that's an important factor too. And we could upside down the market and do some things, but our ratepayers would really suffer, I think. So it'll get there. We're making these baby steps, but the movement's there, the knowledge base, the learnings are all happening. We'll be ready when it starts to really fit.
I'm really glad to hear that there are like significant tests that are going on right now in the state, so it's very reassuring.
I have a little question that might be a little bit off topic. Hopefully it's short and the answer is short. Are the utilities here in Michigan, since they're going to have more and more renewable assets, also looking at getting into the business of generating hydrogen with excess renewables at peak times where peak generation is above peak demand? Because hydrogen has a higher energy density than gasoline does.
Yes.
And so for industrial uses and potentially even for vehicles, it's interesting. Are you guys looking at that?
Everybody is.
Everybody is.
There's a couple barriers to hydrogen. One is generating hydrogen, so it's a technology that's fleeting. Hydrolysis works, there's other technologies that can be applied. Some of them, the power, there's a natural alignment with Michigan and having water that fit. There are other elements of it, like our electric costs, which don't fit so well. And if you think about a gas tank, or a gas pump, you're gonna go fill up your car, the installation cost for that's probably in the range of $150,000. The same pump to provide you hydrogen is $2 million. So you start putting $2 million gas pumps all around, and that cost adds up very quickly. There are technologies like in California that they've started implementing where the state's supporting it, so it's subsidized, and now you can start making a difference. If there's a transportation market that will buy into the hydrogen fuel, great. If there is a need for it from an emissions point of view, another driver, all those drivers line up in California, it makes total sense. Michigan, the economics certainly don't work. We've looked at CNG and other technologies. There are CNG filling stations out there, but hydrogen's difficult. Plus, it's flammable, and nobody really likes driving on 2,000 PSI gas tanks full of hydrogen. I start to worry a little bit about it. So you've got to bridge those gaps. And we're watching California, and we'll see if it works there. Maybe move it here.
Chuck, can you talk a little bit about, so I have a little bit of research background into some of the battery stuff, but not nearly to the extent you know this stuff. So I guess I've often heard of batteries being talked about as a kind of panacea to solve the intermittency problem. And the research that I've seen into this, it starts to seem actually like a pretty daunting kind of infrastructure in and of itself. The capacity for Luddingtons, there's not that much of that, right? These kind of natural things, right? So then you start looking at For every power plant you took down and replaced with wind or solar, you'd essentially need the same amount of big battery storage there. And I think from an environmental perspective, I haven't yet seen convincing evidence that we know what we're getting ourselves into with the chemical side of things and end-of-life handling. Can you talk a little bit about, your understanding of that and how are those challenges being addressed?
Two responses. One is, again, looking at California, when Aliso Canyon had a problem, Aliso Canyon is a large natural gas storage facility, about 3 years ago caught fire and burned for days, I think months maybe, never was able to be extinguished. California ran into a natural gas crisis where they were worried about their electric grid being stable enough because a lot of natural gas plants have been built there. So they turned to the battery manufacturers and said, we have a problem. And I think there were 4 tender offers accepted. There are hundreds of megawatt scale batteries in California. So we're watching to see if that battery can actually provide that reliable service for an extended period. If we build a natural gas plant like a Zeeland, it's got a 40 to 50-year life that's economic. Will a battery last that long, or is the life cycle for a battery going to be so frantically used that now it's way more expensive than we thought? So there's some learnings from that point of view that we're watching to see if batteries really are a panacea to replace larger scale. Certainly the safety aspects of batteries, we need to be mindful of that. In terms of cost, it's a trajectory. The Energy Storage Association, we watch and trend what they have to say about it. I've seen studies done by Lazaro and others that have come and shown the benefits of going to batteries over time and how scalable it's going to be. And then lastly is the end-of-life issue, which again with lithium, right now it's difficult to remanufacture lithium. Nobody really wants to touch it. There's a lot of heavy metals in the batteries. The interesting thing about an EV, so Jay's probably aware of this, the end of life of electric battery in your car, like a Volt, is typically still has it's only consumed 20% of its life. So we can repurpose it. We're repurposing them in different ways. So like a macro scale battery that's only going to be used for 15 minutes a year or something along those lines, perfect use for it because it's going to be available. It doesn't have to be available every day to run down a road, but it's available when it's needed. So that's the kind of application we're seeing now with GM interested in that technology. There's a lot of work on recycling going forward. Again, moving away to flow batteries and looking at other technologies that don't have that end-of-life heavy metals problem probably solve some of the risks you see. So,
Thank you.
a lot going on.
Yeah. Anything else on the battery topic? Thank you very much, Chuck. Okay. Moving on then to our next agenda item, we have our committee updates. Housing, built environment, and energy efficiency. I know that committee was not able to meet this past month. Do we have anything from offline discussions to share from that committee? No. Okay. The Transportation Committee, EV readiness. Want to share where that is? We went through it at the last meeting. We reviewed the.
Yes, there's been a couple of iterations that we're going through, and it still needs some final review. There's some contribution that's going to be made on the code level, which Chuck, you want to speak to?
Yeah, there was some interesting input that was along the lines that we needed to put in additional safety/code provisions in the ordinance as it was written. I think my recommendation is kind of two-pronged. One is continue with the current ordinance. We spent a lot of time and effort to get it to a point where it's at. There may be a couple word changes we might want to take on that will help identify or bridge the problem that was flagged as far as a code issue. And then we can move that whole ordinance process forward and then tackle the code issue as a new business item if that's the direction that wants to be taken by the subcommittee. And so I'd continue to advocate that. I can speak more on the code issue if anybody wants to. Effectively, what was pointed out is perhaps we should be specific about when we ask for a building to be built, let's say, with an EV readiness capability, that we actually size and specify how big the breaker needs to be and how big the service needs to be to that area of the building for future EVs. There's danger in that in terms of technology and in terms of, you know, what is the code gonna say next year and all those things. We really don't need to be that specific. We'd rather be more performance driven and just make sure that the code provisions are followed. And I think we're covered for the time being. And every building's different. Every building will have a different service feeder, it'll have a different electrical configuration, it may have different EV charging. Consumers Energy's parking decks plan for this. We have level 2 chargers in one of our decks. And the breakers and transformer and feeders to that equipment were all sized for the future. They're oversized, if you will. Why get into specifying that every building should have oversized feeders? Well, I don't think we want to go there, but maybe parking decks you do. So we don't want to get into the weeds, I don't think, for this moment. I think we want to keep moving forward with that stepwise change.
Yeah, there was a flurry of emails in the last couple of days on
Yeah.
this topic. And I hope we follow your advice, which I personally agree with. My sense is, in fact, I think Wayne put it aptly in saying, we're writing a zoning ordinance.
Yeah.
We're not trying to deal with building and energy code issues. They're two completely different things. And we could indeed have two documents. The second one might be a technical guidance, or it might be an FAQ, or it might be, here's the person to talk to if you have questions about this, or here persons to talk to. But we really should try to split the issues. And my sense is that we should do the same thing with this issue also about solar being requirement for, there was a proposal from Commissioner Cleavey and from others that we require also that all EV charging be powered by renewable energy. And my sense is the more we add on to a core focused ordinance, the more complicated we make it, the more stakeholders that get involved, the more technical potentially it becomes, and we just slow down the entire process. And so I wrote an email, and just to inject a little bit of humor, in German, they have a saying where they say it's foolhardy to try to create a product, and what they call it is an egg-laying wool milk sow. In other words, normally animals do one thing well. God created, animals to do this. And we human beings should learn from what God taught us, and that is we shouldn't try to pack 50 things into one product or into one ordinance. And I think we would be well advised to do the same thing here. So.
Thank you for that humor. All right.
So to that effect, we are gonna be like reconstraining our boundary, and then, we're gonna be meeting with the planning, we're gonna be having a presentation with the planning commission in April, right? Is that the next thing? Or?
I think that's it,
Because the
yes.
last date I got was April.
Yes,
Was there
that's
April?
my understanding as well,
And then, yeah.
from Emily, yeah.
So so for the March meeting, however, we'd like to have the resolution to be brought forward to the Energy Commission
In support of.
in support of this
The
ordinance.
ordinance, yeah.
Great. So one of you will be drafting and bringing that.
It's a team effort.
Very good. All
Arlene
right,
and I are
all of
taking
you
it
will
on
be
that.
doing that. Very good, okay.
Yep.
Thank you. Energy production, I believe
By
that.
the way,
oh,
with the transportation committee or working group, we talked about this. Our preference is that we call it electric vehicles. And we talked about transportation. There is a transportation commission, and we want to make it clear that this subcommittee or of the Energy Commission is not something that is doing the same thing that the Transportation Commission is doing. And what we would like to focus on is electric vehicles. That's
Yeah.
electric vehicle promotion, whether it's personal, whether it's buses, whether it's charging infrastructure, all those things. We don't want to be giving the impression that we're going to be, a centimeter
thin and a mile wide.
Right.
We want to take one or two things at a time, really focus on those, like I was just saying before, EV charging, and let's focus on that and let's get that done. And then the next thing, and at some point, we may branch out into, broader mobility and transportation issues, but our recommendation is that we name this, what we said, electric vehicles, right? Was it
Transportation,
electrification?
electrification.
No, it wasn't transportation. Was it transportation electrification? Okay, that's what it was, transportation electrification.
Yeah.
Yep, okay. So it could be, that could then branch out into scooters and things like that, but it's really the electrification side of transportation. It's not all these other transportation issues.
Like
Um,
mobility, like.
Pedestrian,
active
biking
mobility,
lanes.
Active transit, non-motorized transit,
Yes,
nothing like that.
right, that's what it was,
It's
yep.
focusing on the electrification of transportation.
Yep,
Side.
Okay,
transportation electrification, yes, thank you.
okay. All right, then energy production, I believe.
Chuck, do you want to talk to that?
I'll just speak for Mark. Mark is the real champion here. I'm just one of the slugs that helps. Mark's running this particular subcommittee. We met once with Josh. He facilitated the meeting. Mark has created a work plan, I'll call it that. Maybe that's a broad definition of it. That talks about what is the production subcommittee going to tackle. Mark is great about big picture, let's tackle it, let's go, and wrote it that way. And I wish we had an army of people to tackle it all, because if we got done with all the things he wants to get done, we'd really get something accomplished. So I'm gonna segue that into, on 1 o'clock on Friday, Valentine's Day. I know you guys aren't doing anything on Valentine's Day. You'd rather sit in a production meeting. At 1 o'clock, we're gonna have a meeting here at City Hall to take the subcommittee report that Mark wrote and try to distill it into a 2020 set of goals. And so that's gonna be presented probably next month by Mark, would be my suspicion.
Did you guys discuss and look at what the energy tax are doing? And, I mean, it seems to me that we should be aligned, at least on the production side of the energy tax, because there's also some efficiency side. What the tax are doing, as you know, because you're one on that team, is, as Josh mentioned before, we've got a whole bunch of projects. We're narrowing those down. We're going through the process that he described. That's going to go through the budgeting process. That's also then going to get, to some degree, resourced by council. And it seems to me it'd be crazy to be working on things that are divergent from that. Is there an eye to coordinating those two, or is the sense that let them go their way and we're going to pick a couple of other things and focus on that and get it done? Or that's still TBD?
I think it's TBD, but I like the idea that we all work collaboratively, and if there are things that are not going to be followed in the budget cycle that make sense for us to do either this year or as a longer-term action, we take those on. But I think the city's not that big. We need to use all the resources we have to get things done. We've learned this on our Energy Commission over years. We've had these huge goals. We never get to the finish line because the goal was too big. If we can slice and dice them into 2020 projects and 2021 projects, we'll get some things done. That'd be my recommendation.
Thank you. Okay. And the last subcommittee, community engagement, Commissioner McCoy, you want to speak to
Sure.
that?
We did mostly a lot of brainstorming about different things that we are interested in doing. I know John talked a little bit about wanting to reach out to car dealerships in the area regarding having more EVs available on lots for people to drive. I think you said most of them only have one of each, so it's kind of hard to purchase an EV if you can't test drive them. So we talked about meeting with them and thinking about maybe involving more of like having a power hour around being able to test drive EVs. We talked about creating like a one-pager type of thing about what each of the subcommittees are working on. Kind of to your point about being able to cast that out to the public, whether it be student groups or other groups we think might be involved, to try to get more volunteers to maybe get some support on some of the projects that we don't have the capacity to take on. See, and we talked about replicating, doing more, I guess, what were they, like solar home tours? Is that what you would call that? But in different neighborhoods so that people can come and see something kind of where they're at versus having ones at the same places. Those are the main things I remember. I don't know if there was anything else major. Just a lot of
Okay.
conversation about different things that we're kind of thinking about and, yeah.
I wonder, one thought, Josh, maybe you could circulate this idea with Missy. I think when we first came up with the 4 subcommittees, it was kind of based on Missy's presentation at our work group in, I want to say it was in December. And she was suggesting that she might be interested in leaning on this group to help plan some of the Earth Day activities and do just some of the kind of community outreach and all of the, the community organizing around that. And I think that was part of what we thought perhaps we could use that subcommittee for. I don't know if she has ideas about how she would like to lean on us,
Yeah.
or how you guys would broadly.
Is the city still planning, wasn't she saying that they want to do something in March? So that'd be next month.
So I think with a lot of these subcommittees, and the first meetings that we had really kind of laid out what's currently going on. So even with the community, the kind of community engagement side, we talked about what we currently have operating at the city, and even with community at large, and thinking somewhat about how we can use that like as a vehicle, basically. And as, a lot of the things with the energy tax, a lot of these recommendations come out, and this kind of gets to the earlier question as well, as far as kind of the energy production subcommittee, kind of, I think, funneling those in, so making sure that we already have a kind of platform or something that's already started, from which we can kind of start to almost like mobilize a lot of the ideas that are going on and that are coming out of the energy TAC and some of the things that are coming up from those recommendations. So that's kind of how we had envisioned it when I talked to Missy, but maybe that helps answer the question.
Okay, yeah, I just want to make sure we're, completely staying aligned and providing support, particularly as the
Yep.
Office of Sustainability and Innovation has so much going on, whether it's on, quite frankly, the community engagement or any of the other subcommittees, that we continue to hear your input about where we could provide really kind of boots on the ground labor and help in that sense. So, okay, great.
Yeah.
Thank you. Well, that is the last of our committee updates. So at this time, we will open it up again for another segment of public input. If anybody from the public who is in our audience this evening would like to step to the podium and speak for a couple of minutes, you're welcome at this time. Seeing no takers, we will move on to the next topic, which is our items for our next agenda. So I captured 4 action items that some of will come back next month. Some are just action items, not for the agenda, but one, to have staff draft a communication around the youth commissioners that we will be adding. And if our community engagement team then wants to get involved in trying to circulate that and solicit those applications to the commission. Second, I said we just need to follow up about the bylaws and find out what their status is, whether they're formally passed or have an effective date. For the next agenda, we will have the EV readiness resolution to vote on. And then to share an update from the Energy Production Subcommittee about the work plan and the 2020 goals. Did anyone else capture something that I missed?
I want to suggest maybe we consider doing one other thing. It's not yet officially an agenda item, but we discussed this in the last Environmental Commission meeting, and that was, I recommended that we look back on the last year to sort of do an accomplishment report. So go back through the meeting agendas and minutes and say, what did we do? And did we, and maybe pairing that with something like, I don't know if we have something to refer to, but what our goals were for last year, or what we sort of thought we would do, and using that as a learning experience. So I actually drafted something for the Environmental Commission and sent it out about a week ago. I haven't actually received comment from anybody yet. And it was sort of interesting that really the only, other than lots of reports, the only accomplishments that we had were passing 8 resolutions. So we passed 2 resolutions in support of the Washtenaw Regional Waste Authority. We passed a resolution in support of the Solid Waste Resource Management Plan, at least the updated one. We passed a couple of other resolutions, but we really didn't accomplish a whole heck, from my perspective, and I haven't heard, as I said, back from anybody to the contrary. And I think it's always, I mean, when in my career, I had performance review every year. I had to write accomplishment report, and we would talk about that with my boss and talk about how do we improve, what obstacles there were, what training I needed to have. And I think this body should be doing the same thing, is looking back and thinking, what did we want to accomplish? What did we accomplish? And what did we not do so well, and how can we improve that? Are we taking on too much? Are we taking on too little? Those kinds of things, and I think that would be instructive. So I would take on the responsibility of putting out a draft for everybody to comment on.
Thank you.
The scary thing about that, John,
Yes.
is you'll create this report for us in March. That's the end of the first quarter already in
I know.
2020. So
I know,
we're moving quick. It's
I know.
amazing how fast this year's gone.
yes.
Okay. Anything else for the greater good? Okay, with that, do you have a motion to adjourn?
So moved.
Second.
Okay, all in favor?
Aye.
Aye.
All opposed? Okay, we adjourn, thank you.